Have you ever wondered what truly makes a website interactive, responsive, or even remembers your preferences when you revisit it? You
Hmm.
know, those pop-up menus, the forums that tell you you've made a mistake before you even hit submit, or even a simple image gallery that cycles through pictures seamlessly.
Yeah, all that dynamic stuff.
Chances are it's JavaScript.
Well,
It's the silent, omnipresent force behind so much of our daily online experience.
it absolutely is.
Yeah.
Many people intuitively grasp that HTML gives a page its structure and CSS gives it its style.
Yeah,
But it's JavaScript that truly breathes life into them.
right.
It handles the crucial behind-the-scenes tasks that transform a static document into a dynamic, responsive experience.
Yeah.
Without it, the internet as we know it would be a very different and frankly much less engaging place.
I couldn't agree more. So today, our mission on the deep dive is to really unpack JavaScript.
Okay.
We're going to explore its fundamental concepts, understand its critical role as the scripting language of the web, and see how it functions as an incredibly powerful tool for both web designers and developers.
Sounds like a plan.
We've got a comprehensive stack of notes on JavaScript that forms the foundation for this deep dive, and our goal is to extract the most important nuggets of knowledge. We want to make complex technical information accessible, useful, and genuinely fascinating, no matter your current level of technical expertise.
Good goal.
Our mission is to demystify JavaScript and show you just how much it enables on the internet. Let's start peeling back the layers.
All right. So at its core, JavaScript is defined as the scripting language of the web.
Okay.
It's seamlessly integrated into millions of web pages globally, and its primary purpose is to inject functionality, enhance design, and add interactivity to those HTML documents. It's what makes a page do something.
So it's not some obscure niche language then. How widely adopted is it really, and what makes it so ubiquitous?
That's a great question because its ubiquity is a key to its impact. JavaScript is the most popular scripting language on the internet, and a huge part of its power comes from its cross-browser compatibility. Think Internet Explorer, Mozilla Firefox, and Opera, Chrome, Safari. Virtually all major browsers support it.
Okay.
This wide compatibility is a primary reason for its popularity and adoption. A script written in JavaScript generally just works everywhere.
That's a huge advantage. So what exactly makes it a scripting language as opposed to, say, a full-blown programming language like C++ or Python? What are its distinguishing characteristics?
Well, a scripting language is generally considered a lightweight programming language, and JavaScript fits this perfectly.
Lightweight, okay.
It's typically embedded directly into HTML pages, making it incredibly easy to integrate functionality without needing separate, complex build processes for every small piece of logic.
Right inside the HTML.
Exactly. Crucially, it's an interpreted language.
Interpreted. What does that mean exactly?
It means its scripts execute without any preliminary compilation. You write the code, and the browser interprets and runs it directly on the fly. This just-in-time execution is a major difference from compiled languages, and perhaps one of its most democratizing characteristics for widespread adoption is its accessibility. Anyone can use JavaScript without needing to purchase a license.
So it's free.
It's fundamentally free and open.
That immediate execution and open access certainly contributed to its rapid growth. Now, before we dive too deep, we have to clear up a common point of confusion that I know catches a lot of people out.
Oh yeah, what's that?
The name, JavaScript versus Java. They sound so similar, but they're not the same thing at all, are they?
You've hit on a very important distinction there. Definitely not. Despite the similar sounding names, JavaScript and Java are, as our sources emphasize, two completely different languages in both concept and design.
Right. Completely different.
Java, developed by Sun Microsystems, is a powerful, more complex compiled programming language. It falls into the same category as languages like C and C++ were, designed for large-scale enterprise applications, desktop software, complex back-end systems.
Big stuff.
Yeah, big, heavy-duty stuff. JavaScript, on the other hand, was specifically designed for the web, focused on lightweight scripting and interactivity directly within the browser environment.
Gotcha.
So think of it less as siblings and more like distant cousins who just happen to share part of a family name. They serve very different purposes and operate quite differently.
That clarity is crucial. So with that common misconception out of the way, let's talk about what JavaScript can actually do. When we say it brings pages to life, what does that really mean in practical terms for someone interacting with a website?
Well, first, it empowers HTML designers in a significant way. Traditionally, HTML authors focused on structure.
Right, the bongs.
Exactly. But JavaScript, with its relatively simple syntax, allows almost anyone to put small snippets of code directly into their HTML pages.
Okay.
This bridges the gap between static design and truly dynamic functionality, making web development accessible to a broader audience.
So you don't have to be a hardcore programmer to start adding some basic interactivity. That's a huge plus. What about making content itself dynamic?
Absolutely. JavaScript can insert dynamic text into an HTML page. Imagine a simple statement like document.write, h1 plus name plus h1.
Right.
This isn't just writing static text. It can write variable text, perhaps a personalized greeting using a user's name retrieved from a form directly into an HTML page.
So it can change the page content.
Exactly. This transforms what was static content into something tailored and alive for each visitor.
Here's where it gets really interesting for me. Reactivity. Websites aren't just passive displays. They respond to us. How does JavaScript make that happen?
This is where events come in, and it's the heart of web interactivity. JavaScript can be set to execute code when specific things happen. These happenings are called events.
Events, okay. Like what?
For example, when a page is finished loading, JavaScript can run some initialization code. Or, perhaps most commonly, when a user clicks on an HTML element, JavaScript can react to that click,
Oh, the click.
triggering anything from an animation to a form submission. This ability to respond to user or browser actions is truly where the web's interactivity begins, and a dynamic user experience is born.
That means it can actually read and change parts of the page after it's loaded, right? It's not just about initial display.
Precisely. JavaScript can read and change the content of any HTML element. This is fundamental to dynamic updates without needing to reload the entire page.
Like a live update.
Exactly. Think of a like button that instantly updates a counter, or a user profile that changes its display based on preferences without a full-page refresh. This manipulation of the web page's content and structure after it loads is a core superpower of JavaScript.
And what about those pesky forms we fill out online? We've all submitted a form, only for it to tell us after a server delay that we forgot a field or entered something incorrectly.
Yes, client-side data validation. This is an incredibly common and crucial use case.
Client-side, meaning in the browser.
Yes, before it gets sent off. JavaScript is incredibly useful here because it can validate form data before it's ever submitted to a server.
Oh, that's smart.
This saves the server from extra processing time and, crucially, provides immediate feedback to the user, significantly improving their experience. No more waiting minutes just to be told you missed a comma.
Definitely a better experience.
It's a huge user experience win right there.
Beyond form validation, what else can it sense about the user's environment?
It can detect the visitor's browser. While modern web development largely aims for cross-browser compatibility, this capability can still be valuable for tailoring specific experiences or addressing unique browser quirks,
Okay.
ensuring the best possible display and functionality for that particular user.
And finally, a word that often pops up in privacy discussions but is also fundamental to how websites remember us.
Yeah.
Cookies. How does JavaScript handle those?
Yes, JavaScript can create and manage cookies. It can store and retrieve small pieces of information on the visitor's computer.
Like little notes.
Kind of. This enables persistent user data, like remembering your login state, your preferences, or items in a shopping cart so you don't have to re-enter them every time you visit.
Right. Convenience.
It's how websites personalize your experience over time, adding a layer of convenience and sometimes sparking those privacy discussions you mentioned.
So that's a big picture of what JavaScript is and what it can do. Now, let's drill down into the absolute foundational elements, how JavaScript handles information. This starts with variables and data types.
Okay.
You can think of variables as the memory of your web page. Expert, can you elaborate?
Certainly. Variables are indeed like containers for storing information. They're used to hold values or expressions that can change during the execution of a script.
Containers. Got it.
Just like in algebra, a variable can have a short, concise name like X or a more descriptive name like car name. They're essential because without them, your website couldn't remember anything.
Okay, so they're placeholders for information. Are there any specific rules for naming them? Like, can I name a variable first car or my car with spaces?
Good question. There are indeed rules, and getting them right is important to avoid unexpected errors. Variable names must begin with a letter or an underscore character.
Letter or underscore. No numbers first.
Right. You can't start a variable name with a number, and you cannot use spaces within the name.
Okay.
And here's a crucial point that trips up many beginners. Variable names are case sensitive.
Ah, so lowercase y is different from uppercase y.
Exactly. They are treated as two entirely different variables in JavaScript. That tiny capitalization error could be a common pitfall.
That case sensitivity is definitely something to watch out for. So how do we actually create these containers and put stuff in them?
You declare variables using the var statement, for instance, of var_x or var_carname.
Just var in the name.
Yep. After this declaration, the variables are initially empty. However, you can also assign values to them right when you declare them. var_x, EXI, or var_carname, Scorpio.
Assigning right away.
And a unique aspect of JavaScript is that if you assign a value to a variable without explicitly declaring it with var first, JavaScript will automatically declare it for you.
Oh, really? So x equals 5 just works.
It would still work. While forgiving, explicitly declaring your variables with var is generally considered good practice for clarity and to prevent potential scope issues in more complex scripts.
Good practice. Okay. And what if I declare a variable, then later declare it again? Does it wipe out its value?
Another good point. If you redeclare a JavaScript variable using var, it will not lose its original value.
It doesn't.
Nope. For example, if you have var_x equals 5, and then later var_x, the variable x will still hold the value 5. Its value isn't reset or cleared just by redeclaring it with var.
Let's see an example of a variable's value changing in action. We have a script here that demonstrates this perfectly, making the first name variable really earn its dynamic stripes.
Indeed. Imagine an HTML script that first declares var first name, then assigns first name, welcome, and writes it to the document.
Okay, so welcome appears.
Right. Then on the very next line, first name, XYZ, is assigned, and it's written again.
So then XYZ appears.
Exactly. The output you'd see would be welcome, followed by XYZ, probably on a new line, depending on how it's written. This clearly shows how a variable's value can dynamically change during the execution of a script, allowing you to refer to it by name to display or modify its content, which is fundamental to any dynamic page.
That's a great illustration of how dynamic these memory containers are. Now that we know about variables, what kind of information can they hold? What are the fundamental data types in JavaScript?
Right. JavaScript has several fundamental data types that determine how information is stored and processed. First, we have numbers.
Numbers? Simple enough.
These are values that can be processed and calculated, whether positive or negative. Importantly, you don't enclose them in quotation marks. So 17 or 3.14 would be numbers.
That makes sense. What about text?
For text, we use strings. These are a series of characters, letters, numbers, or symbols that are always enclosed in quotation marks, either single or double.
Quotes are key for strings.
Absolutely. JavaScript processes strings literally. It doesn't try to calculate them. You'll use strings for text you want displayed on the page, or for values you want to pass along within your script, like a user's name or a message. Greetings, or my cat's name is Whiskers, are examples of strings.
Then there's the concept of true or false, right? Essential for decision-making.
Yes, that's the Boolean data type. It represents a logical entity and can only have two values, true or false.
Just those two.
Just those two. Booleans are fundamental for evaluating conditions, making decisions within your code, and controlling the flow of your script. They're the basic building blocks of logic.
And finally, a value that seems to mean nothing, but isn't quite zero. It's often a point of confusion for beginners.
That's null. Null is a special keyword indicating the deliberate absence of any value. It signifies that a variable or object property has no value.
So not zero, just empty.
Exactly. It's crucial to understand that null is not the same as 0. 0 is a real, calculable number, a specific quantity. Null, however, indicates the absence of an object value, or no value at all. It's a distinct conceptual marker for emptiness, as opposed to a numerical 0.
So we've got our variables, and we know the types of data they can hold. Now, how do we actually do things with that data? How do we change it, combine it, or make calculations?
Right.
This leads us directly into the world of JavaScript's operators and expressions, the verbs of our programming language. What are JavaScript operators?
Operators are essentially tools that allow you to perform various operations like calculations, comparisons, or assignments on data within your script.
Tools for working with data.
Exactly. The most basic one, and often a source of early confusion, is the assignment operator, which is the single equal sign.
Just one equal sign.
Right. It's used to assign values to variables. For example, x equals y means x now holds the value of y. Remember, in JavaScript, means is assigned the value of, not is equal to.
So assigns, it doesn't compare. That's a common point of confusion from other contexts. What about standard math operations?
For standard math, we have the arithmetic operators. These perform calculations between variables and vary values. They include the familiar ones, plus for addition, for subtraction, for multiplication, and for division.
The basics.
Yep. JavaScript also provides a few more specialized ones. Percent for modulus, which gives you the remainder of a division.
Remainder, okay.
For instance, if xy pursue would result in x1 because 5 divided by 2 is 2 with a remainder of 1. And then we have plus plus for incrementing a value by 1 and for decrementing a value by 1.
Plus plus and minus minus.
These are handy shortcuts, and their placement before or after the variable can subtly change when the increment or decrement occurs within a larger expression, which is a common nuance to master.
So plus y means increment e, then use it, and y plus plus means use y, then increment it. That's a good pro tip for new learners. What about shorthand for common operations?
That's where combined assignment operators come in. There are concise shortcuts for common arithmetic assignments, making your code cleaner.
Like shortcuts.
Exactly. Instead of x plus y, you can write x plus equal y. We also have max and percent. For example, if x10 and y5, x plus y would make x become 15.
Saves a bit of typing.
It does, and they're widely used in JavaScript for their efficiency and readability.
Okay, now the plus operator. You mentioned it for numbers, but it does something very different when strings are involved.
Oh, yes.
This is one of JavaScript's first gotchas and a powerful illustration of its flexible or sometimes surprising type handling.
You've hit on a fundamental point here. The plus operator has a dual purpose. When used with numbers, it performs addition, as expected.
5 plus 5 is 10.
Right. But when used with strings, it performs concatenation, meaning it joins two or more strings together. If txt1, what a very txt2, nice day, then txt3, txt1 plus txt2 would result in txt3 containing what a very nice day.
Oh, squished together, no space.
Notice the lack of space between very and nice.
All right, so you have to explicitly add the space yourself. You could define txt1 as what a very with a trailing space, or insert a space directly into the expression like this, txt3, txt1 plus AE plus txt2.
Correct. Both would result in what a very nice day.
And here's the crucial rule that I mentioned, which is often a source of confusion for newcomers. What happens if you try to combine a number and a string with the plus operator?
This is a golden rule in JavaScript.
Yeah.
If you add a number and a string, the result will always be a string.
Always a string.
Always. JavaScript will automatically convert the number to a string and then perform concatenation. Let's solidify this with examples. If x5 plus 5, the result is 10 because both are numbers.
Makes sense.
But if x5 plus 5, the result is 55 because both are strings.
String plus string is string.
Now for the interesting part, if x5 plus 5 or x5 plus 5, in both cases, the result is 55.
Wow. Okay, so number plus string also equals string 55.
Yep. This intelligent or sometimes surprising type coercion is consistent and absolutely vital to grasp for predictable code behavior in JavaScript.
That's definitely a classic aha moment for many learning JavaScript. Moving on from manipulating data, what about testing data or making comparisons to determine if something is true or false?
For that, we use comparison operators. These are used in logical statements to determine equality or difference between variables or values, and they always return either true or false.
True or false outputs.
Exactly. If we take male 5 as an example, x8 is equal to value is false.
Yeah.
x8 is not equal to value is true. We also have the familiar x and for greater than, less than, and so on.
Okay, the double equals, is that the main one for checking equality?
It is one way, but there's a specific comparison operator that checks for more than just value, right? It's really important for preventing unexpected behavior, especially because of that type coercion we just discussed.
Ah, you mean the triple equal.
You're referring to it, exactly. This operator is one of the most important for writing robust JavaScript. It checks for exact equality, meaning it compares both the value and the data type.
Value and type.
Right. So while x5 would be true if x is the number 5 or the string 5, due to type coercion.
Because double equals is loose.
Correct. But x5 would be false if x is the number 5 because 5 is a string.
Strict equality.
This strict comparison is incredibly important for writing predictable and error-resistant JavaScript code, as it avoids unexpected type conversions. You'll often see these comparison operators in conditional statements.
So that helps us compare individual values. What if we need to combine multiple conditions, like if x is true and y is true?
That's where logical operators come in. They allow you to combine or modify conditions, given x is 6 and y 3 in a COA, and checks if both conditions are true.
Double ampersand for A and D.
Yes. So x10 and y1 is true because both by 10 and y1 are true.
Okay.
Or checks if at least one condition is true.
Double pipe for OR.
Right. So x5, y5 is false because neither condition is true, and x not negates a condition.
Exclamation mark for not.
Exactly. So xy is true because x is indeed not equal to y.
And for a more concise way to handle simple if-else logic, there's the conditional operator, sometimes called the ternary operator.
Yes, it's a very neat shortcut for assigning a value based on a condition. Its syntax is variable name, condition, value 1, value 2.
Question mark and colon.
Right. It assigns value 1 if the condition is true and value 2 if the condition is false. For example, greeting, visitor, equals pre, dear S. Dear President Ashere.
Oh, neat.
If the visitor variable equals pre-s, greeting becomes dear president, otherwise it's just dear. It's a compact way to express a simple conditional assignment, which can make your code much more readable for these specific scenarios.
This all leads us naturally into how JavaScript controls the flow of a script. We often need to perform different actions based on different decisions or repeat actions efficiently. This is where conditional statements and loops become essential, acting as the script's decision makers and taskmasters.
Absolutely. Think of conditional statements as guiding the script's path, allowing it to adapt its behavior. Very often, when writing code, you want to perform different actions for different scenarios. JavaScript provides several ways to do this.
So the most basic one would be the if statement.
Correct. The if statement allows you to execute some code only if a specified condition is true. The syntax is if condition, code to be executed.
Just if, then the condition in parentheses.
Yes. A crucial note here for JavaScript is that if must always be written in lowercase letters. Using if in uppercase will generate a JavaScript error.
Case sensitive again.
Always. For example, you could have a script check the current time and display good morning if the time is less than 10. And always remember to use two equal signs, or the strict, when comparing values within these conditions.
What if you want one action if the condition is true, and a different action if it's false?
Then you'd use the if.else statement. This executes one block of code if the condition is true, and a separate block of code if the condition is false.
If this, do that. Otherwise, do this other thing.
Pretty much. The syntax is if, condition. True code, else, false code. So you could say, if the time is less than 10, display good morning. Otherwise, display good day. It ensures that one of two paths is always taken, making your script more robust.
And if you have many possibilities, not just two, like checking multiple conditions.
For multiple distinct possibilities, you turn to the if.else statement. This allows you to select one of many blocks of code to be executed based on a sequence of conditions.
Chaining them together.
Exactly. You check condition 1, if false, check condition 2, and so on. An else block acts as a catch-all if none of the preceding conditions are true.
Like a default option.
Right. For instance, you could have good morning if the time is less than 10, good day if it's between 10 and 16, and hello world for any other time. This provides a clear sequential decision-making process.
Finally, for scenarios with multiple distinct choices based on a single value, there's the switch statement.
The switch statement is excellent when you want to select one of many blocks of code to be executed based on the value of a single expression, often a variable.
Switching based on one value.
Exactly. The expression is evaluated once, and its value is then compared with the values defined for each case in the structure. If there's a match, the code block associated with that case is executed.
Okay.
It's vital to use the break keyword at the end of each case block.
Why break?
This prevents what's called fall-through, where the code would continue executing into the next case automatically, which is rarely what you want.
So break stops it after the matching case.
Correct. If no case matches, the default block is executed. For example, you could use it to give a different greeting based on the day of the week, where Sunday is 0, Monday is 1, and so on.
That covers making decisions. Now, let's talk about doing things over and over again. Loops. Why do we need them, and how does JavaScript handle repetition?
Loops are fundamental for efficiency and conciseness in coding. Very often, you want the same block of code to run repeatedly, whether it's processing a list of items or waiting for a certain condition to be met.
Instead of copy-pasting code.
Exactly. Instead of writing several almost identical lines in a script, loops allow you to perform a task a specified number of times, or as long as a specified condition remains true. JavaScript provides two main types of loops, for and while.
Let's start with for loops. When do you typically use those?
The for loop is ideal when you know in advance how many times the script should run, or when you need to iterate over a sequence.
When you know the number of times.
Right. It has a concise syntax for initialization, condition, increment. It has three parts. An initialization, where you set your counter, like add 0 to, a condition, which continues the loop as long as it's true, like I10, and an increment, how the counter changes each time, like I++.
Setup, check, update.
Precisely. An example would be to count from 0 to 10, displaying the number as I for each iteration, a common pattern for iterating through lists or ranges.
So for loops, you typically know how many times it's going to go. What about while loops?
The while loop is used when you want the loop to execute and continue executing as long as a specified condition is true.
Based purely on a condition.
Yes. You might not know the exact number of iterations beforehand, but you know the condition that must be met to continue looping. The syntax is simply while condition, code to be executed.
Simpler syntax.
It is, but you still need to ensure that something inside the loop changes the condition. Otherwise, you'll end up with an infinite loop, which, for a programmer, is basically the equivalent of accidentally creating a black hole on your computer screen.
Right. Got to make sure it eventually stops.
Definitely. For instance, you can achieve the same 0-10 count as the for loop, but you'd manage the increment I+1 manually within the loop's body.
And there's a lesser-known cousin to the while loop that guarantees at least one execution, even if the condition is false from the start.
That's the do.while loop. It's a variant of the while loop that guarantees the code block executes at least once, because the condition is tested after the first execution.
Do first, then check.
Exactly. So even if the condition is initially false, the code inside the do block will run once, and then it will check the while condition to decide if it should repeat. The syntax is do code while condition.
Okay.
If you had var I0 do document.write, the number is do plus I plus 1, while I0, it would still output the number 0 once, despite I0 being immediately false.
Finally, for loops, we have two special statements that can alter their flow. Break and continue. What do?
These are powerful control statements within loops that give you fine-grained control. The break command will immediately exit the entire loop.
Stops the whole loop dead.
Right. Once break is encountered, the script stops executing the loop and continues with any code that follows after the loop. For example, if you have a loop counting from 0 to 10, but you put if IP3 break, the loop would only output the number is 0, the number is 1, the number is 2, and then stop completely.
So break is the full stop. What about continue?
The continue command, on the other hand, will break only the current iteration of the loop and immediately proceed to the next value or the next iteration.
Skips the rest of this time around.
Exactly. It essentially skips the rest of the code within the current loop block for that particular iteration. Using the same example of a loop from 0 to 10, if you have if I3, the output would be 0, 1, 2, 4, 5, 10.
Ah, it skips 3 but keeps going.
Right. The number 3 would be skipped, but the loop would continue running for the subsequent numbers. It allows for selective skipping within a loop, which is very useful for filtering data.
So we've talked about handling data, manipulating it, making decisions, and repeating actions. Now, how do we organize all this code into manageable, reusable chunks?
Good question.
This brings us to functions. These are essentially the modular building blocks of any well-structured JavaScript program.
Functions are absolutely critical for writing clean, efficient, and maintainable code. A function, also known as a method, is a self-contained piece of code designed to perform a particular task.
Like a mini program inside your program?
Kind of, yeah. Think of it as a reusable code block that will only be executed when it's explicitly called, either by another part of your script or in response to an event.
And a major advantage of functions is that they don't just run automatically when the page loads. That's a huge shift in control.
Precisely. That's a key benefit. By putting your script into a function, you prevent it from executing immediately when the page loads, giving you precise control over when that code runs.
You decide when it runs.
Exactly. You can call a function from anywhere within the page, or even from other pages if it's embedded in an external JS file.
External files too, okay.
Yeah. As for placement, functions can be defined both in the head and in the body section of an HTML document. However, it's generally wise to put them in the head section.
Why the head?
To ensure they are read and loaded by the browser before they are called by other parts of your script or by user actions. This avoids function not defined errors.
Makes sense. Load it before you need it.
Right.
So how do we actually define one of these reusable blocks? What's the syntax like?
The syntax for creating a function is straightforward. Function, function name, param1, param2.
Some code.
Function, name, parentheses, curly braces.
Yep. Here, param1, param2, and so on are parameters. These are variables or values that you can pass into the function, allowing it to work with different data each time it's called without having to rewrite the core logic.
Like inputs for the function.
Exactly. Even if a function doesn't take any parameters, you still need to include the parentheses after the function name.
Empty parentheses if no parameters. Correct. And critically, just like with if statements, the word function must be written in lowercase letters. JavaScript is case sensitive, so if you miscapitalize it, you'll get an error.
Case sensitive strikes again.
Always. Similarly, when you call a function, you must use the exact same capitalization as in its defined name.
Now, if a function calculates something, how does it send that result back out so other parts of the script can use it?
That's the purpose of the return statement. It's used to specify the value that is sent back from the function to the code that called it.
So return gives the output.
Exactly. So any function that is designed to provide a value back must use return. For example, a function named prod, AB, that calculates x equal AB, would then use return x.
Okay.
When you call this function, say product equals prod23, the returned value, which is 6 in this case, will be stored in the variable product. This allows functions to be truly modular and share their results.
And thinking about variables again, there's a really important concept related to functions, the lifetime of variables, or their scope.
Ah, yes, scope. Very important.
What's the fundamental difference between local and global variables, and why does this distinction matter so much for managing data?
This is a fundamental concept for managing data in any programming language, and especially in JavaScript, where it directly impacts how data flows and how robust your code is when you declare a variable within a function.
Inside the function's curly braces?
Yes, that variable can only be accessed inside that specific function. When the function finishes executing and you exit it, that variable is destroyed. These are called local variables.
Temporary, just for that function.
Right. A key benefit of local variables is that different functions can have local variables with the same name without any conflict, because each is recognized only within its own function's isolated environment. They're like temporary scratch pads for that specific task.
So local variables are like temporary containers that only exist for the duration of that function's task. What about variables that need to be accessed from anywhere on the page and persist throughout the page's lifecycle?
Those are global variables. If you declare a variable outside any function, it becomes a global variable, and all the functions on your page can access it.
Available everywhere.
Essentially. The lifetime of these global variables starts when they're declared and only ends when the page is closed. For instance, when the user navigates away or closes the browser tab.
Lasts as long as the page is open.
Correct. This distinction is crucial for managing data flow, sharing information across different parts of your script, and preventing unintended side effects or naming collisions in your code. Choosing between local and global scope directly affects how accessible and persistent your data is.
To tie this back to our earlier discussion about preventing immediate execution, the alert hello world example from our sources illustrates this perfectly. If it's just alert hello world, directly in your HTML, it pops up as soon as the browser hits that line.
Right, immediately.
But if you wrap it in a function, like function display message,
I hear you.
it won't run until, say, an on-click event on a button triggers it. It gives you precise control, allowing you to sequence actions.
Exactly. It's the difference between having a command fire immediately and having it ready to fire only when explicitly told to do so, whether by a user or another part of your program.
Building on that concept of controlling when code runs, let's talk about events and event handlers. This is really what brings true interaction to life on a web page, allowing it to respond to your actions.
Yes, events are key.
What exactly is an event in the context of JavaScript?
An event is simply something that happens within the browser environment. This something can be directly initiated by a user action, like a mouse click or a key press.
User actions.
Or it can be an indirect result of a browser action, such as a page finishing loading, an image failing to load, or a form being submitted.
Browser actions too, okay.
Event handlers, on the other hand, are the JavaScript methods, essentially functions that allow us, as programmers, to control what happens when those events occur.
So the event is the action, and the handler is the response code, the brain of the operation.
Precisely. It's important to keep that distinction in mind. An event is merely something that happens. An event handler is the code that responds to that happening.
Got it.
The elements on a page that can trigger events are known as targets or target elements. Think of a button that triggers a click event. That button is the target element.
The thing being acted upon.
Right. These event handlers are commonly written as attributes directly within the target element's HTML tag. For instance, input type button On-click even handler code.
On-click right in the HTML tag.
Exactly, where even handler code is any valid JavaScript that will execute when that button is clicked.
That makes a lot of sense. Now, our sources break down 3 primary ways that event handlers can be used to trigger events or functions. Let's start with method 1, link events.
Method 1 involves placing an event handler as an attribute within an href tag, like a href foo.html, on mouse over, do something.
So event handlers on links.
Yes. Whenever a user clicks on a link, on click, or moves their cursor over one on mouse over, JavaScript receives a link event. The fascinating part here is that anything appearing in the quotes of an on-click or on mouse over is automatically interpreted as JavaScript.
Even without script tags.
Even without explicit script tags.
And you often see these event handlers directly in a link's href attribute itself. How does that work, and why would you do that?
Yes, there are interesting ways to use href with JavaScript. If you use href hashtag, the browser typically reloads the page and scrolls to the top because it's looking for a non-existent anchor.
The hash symbol.
Right. If you use href javascript.void, this deadens the link, preventing its default navigation.
Stops the link from going anywhere.
Exactly. Which is often done when JavaScript is solely handling the action. And then you can combine deadening the link with executing JavaScript directly in the href, like href javascript.alert.
Ooh, do it again.
JavaScript right in the href.
This immediately calls the alert function when the link is clicked, while also preventing the browser from navigating away. It's a compact way to attach simple interactivity.
So links are a powerful trigger. What about method 2, which focuses on actions within forms?
Method 2 is commonly used for interacting with form elements, which are central to user input. You place an on-click event handler inside a button-type form element, such as input-type button on-click do something.
Clicking buttons in form.
Yes. Any valid JavaScript statement, method, or function can be inside those quotes, while you could put an entire code block directly in the on-click attribute.
Which you probably shouldn't.
Well, the major advantage of using functions as event handlers is that they promote code reusability and make your code much easier to read and understand.
Call a function instead.
Exactly. For instance, for a text field, you might use onChange check field to call a function when the field's value changes, or even place direct logic like onChange if please enter a number greater than 5.
OnChange is another useful one.
Very. If you have multiple commands within an event handler, you simply separate them with semicolons.
Semicolons to separate commands. Got it. And finally, method 3. This one seems crucial for ensuring everything is ready on the page before you try to interact with it, especially for complex layouts.
Method 3 involves onload and ununload event handlers, which are defined in the body or frameset tag.
On the body tag itself.
Yes. The unload handler is executed when the document or frameset is fully loaded. This means all images, subframes, applets, and plugins have been downloaded and displayed.
When everything's ready.
Precisely. This is absolutely crucial for ensuring that all required objects are defined and ready before your scripts try to interact with them, preventing errors like trying to modify an image that hasn't finished loading yet.
Right, avoid errors.
For example, you can set a loaded flag, like onload loaded true, and then other event handlers can check this flag, on-click it, if loaded, to ensure they run safely, knowing the page is fully prepared.
And unload.
On unload is the opposite. It's executed just before the page is unloaded, typically when the browser is about to move to a new page or close the tab.
When you're leaving the page.
Right. It can be useful for cleanup tasks, confirming navigation, or saving user state before they leave.
So JavaScript has a whole host of these event handlers. What are some of the most frequently encountered ones, and what do they typically do?
Among the most common, you'll find onBlur, which triggers when input focus is removed from an element or a window, basically, when you click or tab away from it.
OnBlur for losing focus.
Right. Its counterpart is onFocus, which triggers when an element or window gains focus.
OnFocus for gaining focus.
OnClick is ubiquitous, triggering when an element is clicked. OnChange fires when a form field's value is changed by the user. OnSubmit is critical for forms, triggering when a form is submitted.
Key form events.
Very. On mouse over and on mouse out are for when the user moves the pointer over or off an element, respectively, commonly used for interactive hover effects.
Mouse movements.
These are the workhorses that make web pages truly interactive.
And not all event handlers are available for all HTML objects. This means developers have to know which events apply to which elements, right?
That's right. It's about knowing the specific capabilities of each element. For instance, OnClick is available for button elements, checkbox elements, and hypertext links,
Makes sense for things you click.
Exactly. However, onload is specific to the document, image, and window objects as it pertains to loading states. OnSubmit and OnReset are exclusively for form objects as they relate to form submission and clearing.
Specific to the object type.
Understanding this direct link between an event and the HTML element, it can act upon guides developers on where to attach their interactive logic, ensuring their scripts run predictably and effectively.
So we know how to store individual pieces of data in variables. But what if you have a collection of related data, like a list of car names or a directory of emails?
Right.
You wouldn't want to create 100 separate variables for that. This is where arrays come in, giving us a structured approach to data management.
Exactly. An array object is used to create a database-like structure within a script. It groups multiple data points, or array elements, together, making it much easier to access and use that data.
Like a list.
Very much like a list. You can think of an array like a column of data in a spreadsheet. The name of the array would be like the name of the column, and each individual piece of data, or element, is referred to by an index number, just like a row number in that column.
Index numbers, okay.
Fundamentally, an array is an object, a collection of properties grouped together.
How do you name an array, and how do you access specific pieces of data within it?
Array naming rules are similar to variables and functions. No leading numbers, no reserved words, no spaces. The array object itself is capitalized like new array.
Capital A for array.
Yes. The JavaScript interpreter uses numbers to access the elements. And here's another common pitfall for beginners. Array indexing starts at 0.
Starts at 0, not 1.
Crucially, yes, 0. So if you have 8 elements in an array, the first element is at index 0, and the last one is at index 7. To access an element, you use the array name followed by its index number in brackets, like mycar4.
Square brackets for the index.
Correct.
So if my car contains Chev, Ford, Buick, Lincoln, truck at indices 0 through 4 respectively, then mycar4 would give you truck.
Precisely.
This is perfectly illustrated in that comparison of an array to a column of data image we're referencing, showing my car as the array name, indices 0, 4, and the corresponding data.
Exactly. And an important point is that array elements can be of any type, string, integer, Boolean, or even another array.
You can mix types.
And you can mix different types within the same array, offering incredible flexibility.
Do you have to define the size of an array up front? Like tell it it's going to hold 20 items?
You don't have to. Arrays in JavaScript are dynamic, meaning they can grow or shrink as needed as you add or remove elements.
They grow automatically.
They can. However, you can preset the size if you want to reserve memory space, or initialize it with a certain capacity, like var mycar equals new array, which would create an array with 20 empty elements ready to be filled.
This sounds great for a single list, but what if you have related data that's more like a table with multiple columns, like a list of people, their titles, and their email addresses?
Yeah.
This sounds like multi-dimensional arrays.
Exactly. Multi-dimensional arrays are how you manage more complex relational data, like having several levels or dimensions of data.
Arrays within arrays.
Essentially, yes.
Yeah.
Conceptually, they are similar to a spreadsheet with multiple columns of related data. One common way to create them is to first create a main array, like var email list in array, and then assign subarrays to the elements of that main array.
Okay.
So email list dual might be new array, president, Paul Smith, smith@domain.com, and email list 1 might hold the next person's details.
So to access specific data in a multi-dimensional array, you'd need a double reference, like 2 sets of brackets.
Correct. To get, say, the vice president's email from our email list example, you use email list 12.
1 for the second person, 2 for the third piece of data email.
Precisely. This means you're looking at the second element of the main email list array, index 1, because we start from 0, and then the third element within that subarray, index 2, which corresponds to the email address. So var vp email, email list 12 would give you lstevens@domain.com.
Right.
Our visual aid for multidimensional arrays showing maker, model, and color columns really helps conceptualize this nested structure, like navigating rows and columns in a spreadsheet.
That's incredibly powerful for organizing complex data. What properties do arrays have that are particularly useful in practical terms?
The most commonly used and incredibly useful property is length.
Length, just not link.
Yep. Array name .length returns the number of elements in an array. This is particularly handy when you're cycling through an array using a loop, as it tells you precisely when to stop, ensuring you process every item without going out of bounds.
Perfect for controlling loops.
Exactly.
This is where it gets really interesting, because we can see how arrays, loops, functions, and events all come together in a practical application. We have a great example here, an image banner cycling script.
Ah, the banner cycler, yes.
Can you walk us through the cycle ban function step by step, showing how these concepts weave together?
Certainly. This function beautifully demonstrates many concepts we've just discussed. First, we declare an array called banner_mg and populate it with 3 image file names.
An array of image sources.
Right. We also set up new banner to start at 0 and total ban to be banner_mmg.length, which will automatically be 3.
So total ban dynamically knows how many images there are, which is smart.
Exactly. Inside the cycle ban function, new banner plus plus increments the image index. Crucially, because the plus plus operator is after the variable, new banner's current value is used first, and then it increments.
Use then increment. Got it.
This ensures we start at the first image at index 0.
And how does it loop back to the beginning to create that continuous cycle?
The if new banner equals total ban statement checks if we've gone past the last image. If new banner reaches 3, meaning we've displayed images 0, 1, and 2, it's reset to 0.
Back to the start.
Ensuring the cycle restarts from the first image. The next line, document.banner.src equals banner_im_new_banner, is where JavaScript reaches into the page to update the image source.
Document.banner.src. What's that doing?
It tells the browser, find the image element named banner in the document and set its source, src, attribute to the image file specified by the current new banner index in the banner_mg array.
Changing the image source dynamically.
Exactly. This direct manipulation of the page elements is a core capability we'll discuss more with the document object model.
And how does it keep running every few seconds? Does it just go once?
No, that's where set timeout cycle ban 31000 comes in. This is a built-in JavaScript function that schedules the cycle ban function to run again after a specified number of milliseconds.
Set timeout, wait, and then run again.
Correct. In this case, 3000 milliseconds, or 3 seconds. So every 3 seconds, the function calls itself, advancing the banner. Finally, window.onload cycle ban ensures that this entire banner cycling process kicks off automatically as soon as the web page is fully loaded.
Wait until the page loads first.
Guaranteeing all images are ready before the cycle begins. It's a perfect example of functions, arrays, and events working together in a practical, visually dynamic scenario.
That's a brilliant example of JavaScript's real-world application. Our sources also briefly mention other array properties like constructor, index, input, and prototype, but they're noted as more advanced or seldom used for this deep dive, so we'll stick to the core for now.
Indeed. Those are typically for more complex scenarios related to array internals, and length covers the most common and practical use case for developers.
So we've covered the foundational building blocks of JavaScript itself. Now let's explore how JavaScript actually interacts with the environment it runs in, primarily the browser, through what are called built-in objects and the document object model, DOM.
Right, the connection to the browser.
These are predefined sets of functionalities that extend JavaScript's capabilities, essentially giving it the tools to manipulate dates, perform complex math, handle strings, and crucially, see and interact with the web page itself.
Exactly. Let's start with the JavaScript date object. As its name suggests, its purpose is to create and manipulate dates and times. You create a date object simply by var myDate equals new date.
New date.
Yes. When you do this without any arguments, it automatically holds the current date and time as its initial value.
Gets today's date and time automatically.
Right.
Can you set it to a specific date or manipulate it, like calculating 5 days from now?
Absolutely. You can set a date object to a specific date, like myDate.setFullYear 2010-14, to set it to January 14, 2010.
Wait, month 0?
Ah, good catch. Yes, months are 0 indexed in the date object, so 0 is January, 1 is February, and so on. Another little JavaScript core.
0-based months. Okay.
What's particularly powerful is that it handles date arithmetic intelligently. If you want to set a date 5 days into the future, you could do myDate.setDate, myDate.getDate, +5.
Just add 5 to the day.
Yes, and the date object automatically handles shifts in month or year if adding days crosses those boundaries. It also allows you to compare 2 dates using simple comparison operators, like if myDateToday.
Comparing dates directly.
Making it incredibly useful for things like event calendars, countdowns, or scheduling.
Very useful. What about mathematical operations beyond basic arithmetic?
For more advanced mathematical tasks, JavaScript provides the math object. The key aspect here is that math is not a constructor. You don't create an instance of it with new math.
No new math.
No.
Yeah.
All its properties and methods are called directly on the math object itself, like math.pi or math.sqrt16. Think of it as a static utility collection, like a drawer filled with mathematical tools.
So it's like a static utility collection. What kind of constants and methods does it offer that a developer might regularly use?
It provides several useful mathematical constants, including math.pi for geometry and math.e for natural logarithms, among others for more advanced calculations.
Pi, the classics.
Right. For methods, math round 4.7 rounds to the nearest integer, giving 5 math.random, returns a random floating point number between 0 inclusive and 1 exclusive.
Random numbers, always useful.
Incredibly useful for games or dynamic content. You can combine math.floor with math.random to generate a random integer within a specific range. For example, math.floor, math.random would give you a random integer between 0 and 10.
Or to chop off the decimal. Okay. And for manipulating text, we have the string object.
Yes. The string object is used specifically to manipulate stored pieces of text. The most common property you'll use is length, which returns the number of characters in a string.
String length again.
So if var txt hello world, then txt.length would return 12. For methods, txt.toUppercase converts a string to all uppercase letters, transforming hello world into hello world.
Uppercase, lowercase, that sort of thing.
Exactly. There are many other methods for searching, replacing, and extracting parts of strings, providing powerful ways to process textual data.
Okay, so those are some powerful built-in tools. Now let's get into how JavaScript actually sees and interacts with the web page and the browser itself.
Right, the DOM.
This is where the document object model, DOM and browser objects come into play. You could say the DOM is JavaScript's eyes and hands on the web page.
Precisely. JavaScript interacts with the browser and the web page through a hierarchical structure of objects. This structure, the DOM, literally allows your script to see every button, every image, every piece of text.
It represents the page structure.
Yes, and then reach out to change it in real time. At the very top of this hierarchy is the window object.
The window object represents the browser window itself, right? It's the highest level.
That's right. A window object is automatically created for everybody or frameset tag. It's the top-level object, acting as the global object for all JavaScript code running in that window.
The main container.
It has several key properties. For instance, document provides access to the HTML content of the current page. History is for managing browser history. Location deals with the current URL, and name can store the window's name.
And what about methods? I know alert is a window method, for example, but what else can it do to control the browser?
Indeed. Beyond user interaction methods like alert, confirm, and prompt, the window object offers extensive methods for programmatic control over the browser window itself.
Like opening new windows.
Yes, you can open or close new browser windows, manage their blur and focus states, or use set timeout and set interval for timed actions, like our banner cycling example.
Set timeout is a window method too.
It is. It also includes methods to move by, or move till the window, resize by, or resize to it, and even scroll by or scroll to specific positions on the page. It's truly the command center for the browser window.
Next down the hierarchy is the document object, which seems to be the gateway to the actual HTML content.
Exactly. The document object represents the entire HTML document itself. It's part of the window object, and you access it via window.document, though often simply document is sufficient because window is the global object.
So document is the page content.
Yes. This object is your primary interface for interacting with the content of the web page. Every element, every piece of text is accessible through this object.
So it gives you access to elements on the page in a structured way.
Yes. It provides key collections that are essentially arrays of specific HTML elements like document.forms, document.images, and document.links.
Collections of forms, images, links.
Right. These allow you to access all form tags, images, and links on the page. Other crucial properties include document.body, which gives direct access to the body element, document.cookie for managing cookies specific to the current document, and document.url for the document's address.
And how do you select specific elements from the document or add new content using its methods?
The document.write and document.write methods are used to write HTML expressions or JavaScript code directly to the document, though used less often now. But more powerfully and essential for modern DOM manipulation are document.getElementByLead, document.getElementsByName, and document.getElementsByTagName.
Get element by ID. That sounds important.
Hugely important. These methods are crucial for selecting specific HTML elements to read their content, change their attributes, or even modify their structure. They are the backbone of dynamic web pages, allowing JavaScript to pinpoint exactly what it needs to interact with.
Moving on to user navigation, we have the history object. This one isn't technically part of the HTML DOM, is it?
That's correct. The history object is a pure JavaScript object, not an HTML DOM object, and it's automatically created by the JavaScript runtime engine. It essentially contains an array of URLs that the user has visited within the current browser window.
The browser's back-forward list.
Pretty much. It's accessed through window.history. Its key property is length, which tells you how many elements are in the history list. This object is interesting because it gives your scripts the ability to navigate back and forth programmatically.
Like clicking the back button with code.
Exactly, using methods like history.back, history.forward, or history.go. It can be useful for single-page applications or guided workflows.
Now, let's zoom in on interactive elements. The form object is crucial for handling user input.
The form object represents an HTML form tag. For every form tag in your HTML, a form object is created. Its most important collection is elements.
A list of all the fields in the form.
Exactly. An array containing references to every input element within that form. Key properties include action, where the form data is sent, method, like GDT or POST for HTTP requests, and name. Its methods include reset, to clear all form values, and submit, to programmatically submit the form.
So you can submit a form with JavaScript.
Yep, giving JavaScript full control over form interaction.
Images are everywhere on the web. What about the image object?
The image object represents an emoji tag. For each emoji tag in an HTML document, an image object is created, allowing JavaScript to interact with it. Key properties include src, the image's URL, alternate text for accessibility, width and height, and name.
Standard image attributes.
Right. And a complete property even tells you whether the browser has finished loading the image, useful for ensuring animations or manipulations don't happen before the image is ready.
And for clickable regions within images, often used in interactive maps, there's the area object.
The area object represents an area tag, which defines a clickable region within an image map. It's commonly used for interactive graphics, where different parts of an image are links.
Image maps, right.
Its key properties include chords, the coordinates defining the clickable shape, and href, the URL for the link, allowing JavaScript to interpret or modify these interactive zones.
Finally, what information can JavaScript gather about the user's browser itself? That would be the navigator object.
The navigator object is another pure JavaScript object, not part of the HTML DOM. It's automatically created and contains information about the client browser.
Info about the browser they're using.
Exactly. Its plugins collection provides references to embedded objects within the document. Key properties include app name, the browser's general name, app version, platform and version details, and user agent, the full user agent string sent by the client, which contains detailed browser and OS information.
The user agent string, okay.
It also includes platform, the operating system, and cookie enabled to check if cookies are enabled in the browser. This object is useful for tailoring experiences or debugging based on specific browser capabilities or environments.
That's an exhaustive overview of the core objects JavaScript uses to interact with the web and the browser. To bring all these concepts together and show their power in a real-world scenario, let's dive into a practical application. Client-side data validation using a ZIP code example.
This is where theory meets practice in a very tangible way. The problem is simple. How do you ensure that user input, like a ZIP code, meets specific criteria before it's sent to a server?
Right, check it before sending.
Sending invalid data to a server is inefficient, wastes resources, and can cause errors. Client-side validation using JavaScript provides immediate feedback to the user, saving server processing time and greatly improving user experience by catching mistakes instantly.
So let's walk through the validate ZIP function that's provided in our sources. How does this script work its magic to ensure a valid ZIP code?
Okay, the validate ZIP function takes a field, the input value from the user, as its argument. Inside, it first defines a string valid containing all acceptable characters for a US ZIP code, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Just numbers and the hyphen.
Right. It also initializes a hyphen count variable to 0.
First, it performs a quick length check.
Yes. It immediately checks if field.length is neither 5 nor 10 characters.
Has to be 5 or 10 digits long.
Correct. If not, it displays an alert. Please enter your 5-digit or 5-digit plus 4 zip code, and crucially returns false, preventing any further processing and stopping the form submission right there. This handles the most basic requirement for a valid ZIP code format.
Then it goes character by character to ensure validity.
Exactly. It enters a for loop that iterates through each character of the field string. In each iteration, it extracts a character into a temp variable.
Checks each letter or number.
It then performs two checks. First, it sees if temp is a hyphen. If so, it increments hyphen count. Second, and critically, it uses valid.indexOfTemp into 1.
Index_of again. Checks that the character is in the valid string.
Precisely. The indexOf method returns the position of a character within a string, or megas1 if the character not found. So if indexOf returns megas1, it means temp is an invalid character not allowed in the ZIP code.
Not a number or a hyphen.
Right. In that case, it immediately alerts invalid characters in your zip code, please try again, and returns false. This loop ensures only numbers and hyphens are present.
So it's making sure only numbers and hyphens are allowed. What about the hyphens placement for the 10-digit format, or if there's too many hyphens?
That's the final, more complex check. Hyphen count 1, field.length 10, plus field.char 5.
Okay, break that down. Two parts with an OR.
Yes. The first part, hyphen count 1, checks if there's more than one hyphen, which is invalid for US ZIP codes.
Only one hyphen allowed max.
Correct. The second part, field.length 10 plus field.char 5, applies specifically to 10-digit ZIP codes. It checked if the length is 10, and if the character in index 5, the sixth character, remember 0 indexing, is not a hyphen.
So for 10 digits, the sixth character must be a hyphen.
Exactly. If either of these conditions is true, more than one hyphen or 10 digits without the hyphen in the right place, it means the format is wrong. In this scenario, it alerts the hyphen character should be used with a properly formatted 5-digit plus 4 zip code and returns false.
And if it passes all those rigorous checks?
If the loop completes and none of the return false conditions are met, it means the ZIP code is valid according to these rules, and the function finally returns true.
Returns true if it's valid.
This true value signals that the input is clean and ready.
Now, how does this function integrate into an actual HTML form to stop invalid data?
The HTML integration is straightforward and powerful, perfectly demonstrating how JavaScript controls form submission. The form itself is defined with form, name, zip on submit. Return validate ZIP.
OnSubmit calls the function.
Exactly. The onSubmit event handler for the form is set to call our validate ZIP function, passing it the value of the zip input field, this.zip.value. The critical part here is return validate ZIP.
Why return the result?
If validate ZIP returns false, the onSubmit handler will also return false, which by default prevents the form from actually submitting to the server.
Returning false stops the submission.
Exactly. This effectively stops invalid data from ever leaving the client's browser, exactly what we wanted, providing that immediate pre-submission feedback.
Wow. That was a thorough deep dive into JavaScript. We started by defining it as the lightweight, ubiquitous scripting language that breathes life into HTML pages.
The language of the web.
Making that crucial distinction from Java. We then explored its fundamental building blocks, variables which act as the memory of your web page, storing information.
Those containers.
And the essential data types they can hold, numbers, strings, Booleans, and that distinct null value.
Right, the basic types.
We moved on to how JavaScript takes action with that data through operators for arithmetic, assignment, and that crucial string concatenation, highlighting JavaScript's unique handling of the plus operator.
The dual-purpose plus sign.
We saw how it tests for truth with comparison and logical operators, including the vital equals for strict equality, which is a key to robust code.
Strict equality, yeah, very important.
We then learned how conditional statements like if, else if, and switch allow our scripts to make decisions.
Reaching logic.
And how for, while, and do. While loops efficiently repeat actions, with break and continue offering fine-grained control.
Making decisions and repeating tasks.
And then we discovered the power of organizing code into reusable, modular blocks using functions, understanding the critical difference between local and global variable scope, and why it matters for data management.
Functions and scope, key for organization.
We then saw how JavaScript brings true interaction to life through events and event handlers, allowing web pages to respond to user actions like clicks or page loads in incredibly dynamic ways.
Making pages react.
Whether through links, forms, or even the page's body itself.
Finally, we looked at how JavaScript manages collections of data through arrays, including multidimensional arrays for complex structures.
Lists and tables of data.
And how powerful built-in objects like date for time, math for calculations, and string for text manipulation extend its capabilities.
Built-in tools.
We wrapped up by exploring the document object model and browser objects like window, document history, and navigator, which are JavaScript's direct interfaces to the web page and the browser environment.
How it talks to the browser and the page.
Allowing it to see, touch, and manipulate almost everything you encounter online.
This deep dive has truly revealed JavaScript as more than just a programming language. It's the invisible force that crafts so much of our online experience, allowing web pages to respond, remember, and adapt to us in real time. It's what makes the web interactive, dynamic, and truly engaging.
And that, I think, is the key takeaway. It's everywhere, influencing virtually every interactive element you encounter online, from the simplest button click to complex data validation.
So what does this all mean for you, our listener? Given JavaScript's pervasive nature and its ability to interact with almost every part of a web page and browser, what new, innovative ways could you imagine leveraging its power?
Yeah, think beyond just websites.
Right. To solve everyday problems or create entirely new user experiences, perhaps even beyond traditional web pages. Think about JavaScript not just as code for websites, but as a versatile tool for creative problem solving in an increasingly digital world.